Hey everyone, welcome to another Power Monkey podcast. On today's episode, Chad and I interview Evan Peikon. Evan is a coach with Training Think Tank, and he is also a former middle distance track and field athlete who has transitioned into the exercise physiology and sports science world. He is a coach, yes, but he takes an approach that is very heavily science-based. I think you'll get it from the podcast that his knowledge around these topics is very, very high. It's incredible to talk to someone who knows the inside and out of the science that goes along with his programming and his approach, as well as Evan does. I know I was finding myself having asked more and more questions on topics that have been coming up pretty regularly on our podcast recently. I think this can just be the starting point into having Evan again on in the future. An incredible knowledge base, an incredible resource, and I hope you guys find this one useful. All right, Evan, thanks so much for taking the time to be with us today. I really appreciate it.
Yeah, thank you guys for having me on.
So for a little bit of background on who you are and where you're coming from, can you just tell us a little bit and our listeners what your background is as a specialist? You're a coach, you're a physiologist, you work a little bit with Training Think Tank. Can you give us a little bit of background on what you guys are doing and kind of your background specifically?
Yeah, so like you said, I think most people would probably know me best from the work that I do with Training Think Tank, which is a company that primarily works with CrossFit competitors ranging from intermediates up to some of the top games athletes. So I'm a coach for that company. I'm also a physiologist and sports scientist for the company. So I do a lot of the physiological testing on our games athletes and a lot of the research for the company. Then outside of that, I'm also just more broadly a physiologist and researcher. So I work for a few different companies doing consulting and product development and research.
And how long have you been in the business doing this stuff?
Professionally now for about 6 or 7 years.
And during that time, working a lot with CrossFitters specifically?
Yes, so I actually started in endurance sports primarily and then transitioned into CrossFit. And then over the past 3 or 4 years, I've kind of been branching out into other disciplines. So doing some work with military and special forces, some strength athletes. So kind of cutting my teeth in some different areas at this point.
Very cool. And one of the things that's really cool that you guys are doing, just the Training Think Tank in general, seems to be a really solid high-level group of professionals, a lot of different areas. Can you just talk about what the Training Think Tank is and how you got drawn to it and why you wanted to be a part of it?
Yes, so the idea behind Training Think Tank was to quite literally have a think tank that focuses on training. So the name is pretty literal. And the idea that we want to get specialists from different areas and coaches with different athletic backgrounds. So I have a track and field background. We have coaches that were hockey players, CrossFit Games competitors, wrestlers. And the idea was that all of us are going to focus on similar problems, which is trying to improve human performance, broadly speaking. So the idea is that we could all collaborate, bring different things to the table, argue with each other, and see if we could come to some conclusions of how to best train athletes. And the way that I originally got started with the company is that I'd gone through a mentorship program with the owner of the company, Max Hag, maybe 5 or 6 years ago. And after going through that program, we had stayed in touch over the years, and I told him about some of the research I was doing. And then that eventually led to me moving down here from New York to work for the company.
From New York?
Yeah.
Oh, awesome. Very, very cool. So, we do some similar stuff with Power Monkey, bringing together a collection of experts in certain fields. And I feel like there's a lot of similarities to what you guys are doing. And I love that. I love trying to bring high-level technical understanding to the masses, to the people that are going to be using it on a regular basis. So really appreciate what you guys are doing, and we think you guys are doing a really good job of it. And there's a few things that I think stood out from researching some of the stuff that you're doing that Chad and I wanted to kind of delve into a little bit more, if that's okay with you.
Yeah, for sure.
So just on the programming side, and this is something that I've heard you say before, and I think it's really important because people kind of have maybe misconceptions in terms of what programming looks like, what periodization looks like. And one of the things that stood out to me with your approach specifically to programming and to periodization is this idea of dynamic programming. Mm-hmm. And I really love this idea, and it has to do more with just the individual rather than a global approach to a plan. Here's a blanket plan that's going to work for everyone moving forward. Can you describe what dynamic programming means to you and how you apply it to your clients?
Yes, so at the simplest level, the first thing that I'm always thinking about the dynamic programming is I think less about protocols and methods and more about what is a person's individual physiology. I'm sure you guys have seen in your respective fields that there's a lot of debates on what types of training protocols are the best. In my background with middle distance running, there's the epic debates of, is high intensity the best thing for athletes? Is low intensity, high volume the best thing? And there's these divisive camps that all have their one thing. And at the end of the day, everything works, and people tend to kind of shout about the thing that works for them. But what I've always been interested in is, well, why is it that for this athlete, high intensity does work really well for them, but high volume, low intensity doesn't, and vice versa? And what it essentially comes down to is your physiological predisposition and your limiting factor in your physiology is going to determine what the best protocol is for you. So if a protocol that you do is specific to your limiter, it's going to make you better. If it's not, it probably won't. So the first thing that I always start with is trying to understand what is limiting this athlete from performing better. And we go after that. But then from a programming and periodization standpoint, rather than taking these long views of saying, we're going to do a cycle for 4 weeks and we're going to move on to this training focus, I tend to program a little bit different. So if there's a quality that's relevant for an athlete to do for their sport, they're training everything at all times of the year. And the only thing that really changes is the relative volume and frequency of each training quality that they're doing. So in this way, we're never really planning their training that far in advance. We're just giving them a training week or a few training days, seeing how they respond to it, and using that to decide where we go from there. So we're always taking a few steps, looking around and seeing where we are, determining what the next few steps are, and we're using periodization and programming in that way.
Mm-hmm.
Yeah.
So yeah, I think that's a very elegant way to be doing it. And the thing you mentioned early on in the process, I think, is a critical step, this idea of figuring out what the person's big limiter is, right?
Mm-hmm.
Now, what kind of assessment process do you normally go through with an initial client to be able to say, all right, we know these are your strengths, here are your weaknesses, this is how we're going to attack this. This is a uniform blanket way that you normally go through an assessment process?
So I don't have a standard way of doing it. A lot of it is going to depend on what client has access to. So a lot of times if we have someone on site, or if someone has access to doing physiological testing with devices like a Moxie monitor, which is a near infrared spectroscopy device that measures oxygen saturation in the muscle, if I could get access to that and I could put an athlete through testing in that way, that's going to really shortcut the process for me, because I could actually look at blood volume changes in their muscle in live time and look at changes in oxygen saturation. And I could use that live physiologic data to figure out what an athlete's limiter is. But if I'm just working with an athlete off the street, I need to figure out different ways to get that same information without running them through all this expensive testing that they might not have access to. So one way that I might handle this, if a client just comes to me remotely and they want to compete in a mile run, for example, I need to figure out what their limiter is without equipment. So what I might do is run a critical power test. One way that we could do that is to have this athlete run a mile, a 2 mile, and a 3 mile. And we'll calculate their actual power output in wattage for each of those and the time that it takes. And we could create what's called a power duration curve. And using that, we could more or less predict their PR pace on any given distance between about 2 minutes and 90 minutes. And what we could also do is look at the shape of that power duration curve to try and understand if they're more limited by their oxygen delivery or their oxygen utilization. And this is kind of a rough proxy of what their limitation is, because I'm not really taking any measurements.
Mm-hmm.
But the way that I explain it is it's kind of like a pin drop on a map. We drop that pin, it at least gives us some grounding and tells us some sense of our direction for where we go from there. And then we could use that athlete-centric coaching process to learn more things about that individual as we go. So I don't really have like a hard and fast testing process, and I don't even take testing, not that I don't take it seriously, but I don't like to base everything off testings. It's such a limited snapshot. So I kind of treat the first few weeks of working with an athlete as a testing phase.
Mm-hmm.
Yeah. Yeah, really, as you were describing that, and I know it was specific to someone with the goal of running a mile, but it sounded a lot like a lot of the stuff that Chris does, Dave.
Yeah.
And having them run 1 mile, having them run 3 miles, and see, what their rate of decrease is and all that good stuff. Evan, I think you explained it a little bit more elegantly than maybe we've heard Chris explain it. But it really makes me wonder as well. You're talking about maybe not these initial tests, but you're working with someone through the course of a couple of weeks, and those are your testing periods. And I absolutely agree. I think initial assessments are great. They're starting blocks, but you're not going to get a complete picture until you work with someone for at least a couple weeks and probably more. For me, I need to see, probably at least a month before I can really write the best individualized weightlifting program for them. But, I wonder as a whole with the group of people that you guys work with the most, and I know you said you were getting into other areas, but let's say CrossFitters, what are the few most common changes that you find yourself making to CrossFitters programming?
Yes, I think one of the biggest things that we see with CrossFitters is if we had to break down the most common physiological limitations, there's two main camps that we see in CrossFitters when they're competitive. We see athletes that have really good oxygen utilization in their muscle, and they have really good cardiac output, but they're limited by their ability to get enough oxygen into their body and to breathe enough carbon dioxide out. The second camp that we see in CrossFit is athletes that also have good oxygen utilization, and they have a really strong respiratory system, but they have lagging cardiac output. So respectively, we would call these like respiratory limited athletes and delivery limited athletes. When I first start working with these populations, some of the main things that I'm trying to do is implement protocols that I know are going to be effective for attacking those limitations, because that's our low-hanging fruit. The really common thing I see is the delivery limited athletes. If you wanted to put like some names to these types of limitations, the classic delivery limited guy in CrossFit would be like a Jason Klepa type build. These guys that put on a lot of muscle from doing CrossFit tend to be a lot more powerful and maybe don't do as well in these longer events. For these individuals, a lot of times when they'll come on board with us and they're working with us, we talk to them about their common issues. It's usually they get pumped out doing Metcons. They kind of get that classic blowing up sensation. A lot of times they struggle to improve their aerobic capacity and they have a lot of trouble on these longer Metcons. And for them, I'm always trying to implement things that will improve that. And a lot of times it's different than what they would expect. So classically, these athletes might do a lot of like traditional muscular endurance training. They might do a lot of easy aerobic work to try and improve those limitations. But understanding how that physiological limitation occurs, those two types of protocols don't really make that much sense for these individuals. So a lot of times I'm implementing things to try and improve their muscle coordination so they could relax their muscles faster and get steady blood flow to the tissue. Or I'm trying to improve their cardiac output through well-structured intervals that are going to allow their cardiac system to catch up to the oxygen utilization in their muscles. So we take a lot of really unconventional approaches, and oftentimes when I start working with athletes, I'll even tell them like, hey, a lot of the stuff that I'm going to have you do is going to look pretty weird. Some of it you might not be used to, but we tend to get pretty good buy-in because we do have that social proof from working with a lot of high level CrossFitters. So that tends to be like my entry point.
Yeah, I like when stuff is weird in a program when it's different. If it works, right? That's
Yeah.
always a good thing. It needs to work for sure. And so I think a lot of the stuff that we give out, or that I would give out in a weightlifting program, for example, would look a little bit different than what are in most other programs. But it's all kind of going back to the basics. Going back to the basics and making sure that those holes are filled in and those things are being accomplished. But I went back and looked at some of your Instagram content, actually a lot of it, and there's so much of it that's very interesting to me. We won't be able to dig into all of it, but one of the things that relates to what we're talking about now and just programming in general, one of the posts was about what can coaches learn from computer programming. I was very intrigued by that. Can you talk about that a little bit? You were relating computer programming to actually being able to write in a language and in a way that makes sense to the athlete.
Yeah, so there's this idea when we think about computer programming, like there's this idea of a computer language. And what a computer language really is if we want a computer program to carry out a certain task, we can't just like type on our laptop in the text editor like, hey, do this computer. Computers don't speak English, they speak computer code. So what the role of a computer programmer is to translate their intentions into a form a computer could understand. But because computers don't really think in the way that we do, whatever that programmer writes, the computer is going to carry out that task or code, even if it doesn't actually make sense to do it. So there's this phrase in computer science of garbage in, garbage out. Like if you write a pretty shitty computer code, your computer is going to carry it out and it's going to produce nonsensical answers. And I like to think of program design in the same way, because when we're writing a program, we're translating our intentions into something an athlete could understand. As a physiologist, I'm not writing in my athlete's program, hey, today I want you to maximize your stroke volume and then maintain that for this fixed period of time. The athlete's going to look at that and they're going to be like, dude, what the hell are you talking about? Like, what is stroke volume? What's ejection fraction? Like, these words don't really mean anything. So instead, I turned it into the form of a workout. Hey, hold this percentage of your max sprint speed on the salt bike for X duration and so forth. But where that garbage in, garbage out, to kind of use that computer science term, comes in, is if I want an athlete to improve their stroke volume, I have to actually know a protocol that is going to improve their stroke volume. If I write just a arbitrary interval workout and give it to that athlete, they're going to carry out that program just like a computer would, and they may or may not get the desired results. So in the same way that a computer will take a code that doesn't really make sense and produce a nonsensical answer, for an athlete, that nonsensical answer would be an adaptation that doesn't actually get us our desired result. So as a computer programmer or as a coach, it's up to us to understand what our algorithms are actually doing. And I think of program design like an algorithm when we're coaching. And then if we know what our algorithms are doing, then we could actually have a better shot at getting our athlete to produce the response that we want.
Yeah, absolutely. I think, for me, I spend a lot of time um, talking to athletes about what do I mean when I'm cueing you, or what does it mean to cue? What does it mean for you to take in that cue? And I try to, upfront develop a language with them that we can speak with very, very simply and straightforward. But if I don't do that, there's obviously a lot of spinning wheels. And I think a lot of coaches fall into the trap of they just jump in and they start cueing on random areas of the movement and without any, you know, um, language that they've developed with the athlete up front. And I think that causes a lot of confusion. And, maybe the athlete even gets to the point to where, and I've heard athletes say this to me, they get to the point to where they're just kind of, um, whatever the coach is saying to them is in one ear and out the other, so they never make any more changes or improvements. So I think a language is so very important. Now, when you were talking about that, I know you were giving just a somewhat of a random example, but what would be an example of a good protocol to help improve stroke volume?
Yeah, so an example of this, I like to pick like a fixed workout and talk about how do we tweak this to get different adaptations. So I'm sure having some involvement in CrossFit, think of like a standard protocol that a ton of people do, 500-meter row at your 2K pace, and you just do a bunch of repeats of that. It's pretty cookie cutter, and everyone's probably done some iteration of that if they've been involved in CrossFit. That's not going to be specific to stroke volume, but that 500 meter, let's say you have a 7-minute 2K, so you could do a 500 meter at a 145 pace. But now what if we structure that interval differently? So instead we do 100 meters at 155, 150, 145, 140, 135. The average pace is still 145 for 500 meters, but now we've structured that interval differently. And even though it looks the same on paper and it averages out to the same speeds and the same distances, it's actually going to get us a different adaptation, because now what's going to happen is you're going to gradually desaturate the muscle of oxygen at a rate that the heart and cardiac system could cope with and deliver blood and oxygen to the muscle. So you almost create this inverse supply and demand relationship between cardiac output and oxygen utilization. Versus if you just did that fixed 500-meter interval at your 2K pace, you're not really going to be maximizing that adaptation, because there's this process called cardiac lag. If you just go straight to a high intensity, your heart's not going to be able to catch up with that. And if you're an athlete who's limited by your cardiac output, you're going to be in a lot of trouble, because if you push past your threshold, whatever your limiter is not going to be able to cope with that. And that way, we're just kind of relying on our compensation patterns to keep us going. Then if we want to twist that again, we could even say, what if we structure it the opposite way? It's still going to be a 500 meter at a 145 average pace. But what if we go 125 meters at 140, 125 meters at 143, 125 meters at 146, and 125 meters at 149? It still averages to the same pace, but now we're stressing the respiratory system more, because you're starting at a high percentage of your VO2 max, and now that gradual decrease in pace is allowing you to sustain that maximal oxygen consumption. So in this way, we could have 3 athletes. They're all doing a 500-meter interval at a 145 pace, and we're targeting 3 completely different physiological adaptations. So a lot of what I try and do from a coaching standpoint, when I first start working with an athlete, I'm not making huge overhauls to their program. I'm just seeing like, what are you already doing? And how could we kind of tweak and modify this a little bit to get different adaptations? And then that way, it's not like a huge jarring effect when you kind of overhaul someone's program.
Can I jump in for a second, because there's
Yeah.
been a topic here that I'm gonna just be ignorant here and talk a little bit about the oxygen component. And I'm bringing it up because we've been having a lot of people on the podcast recently that have been talking about breathing. We had James Nestor on this week. We had Patrick McEwen recently, and breathing obviously has become a really hot topic lately. And the things that they've been talking about is that the discussion point of oxygen consumption and oxygen in the blood is kind of overblown, where most of the time the amount of oxygen that is readily available in the body is much higher than we normally think. And the issue is actually that CO2 levels are very low, and it doesn't allow for the distribution and the actual utilization of the oxygen to be utilized correctly. Now, I would love to get your take on what you're talking about, whether or not oxygen levels are at a high enough level and things like that. What is your take on oxygen versus the importance of CO2 during this discussion?
Yeah, so this is where we get into a lot of people. You ask someone, what's the function of your respiratory system? And they say to get oxygen into the body. That's not actually true. That's the secondary function of the respiratory system. The primary function is actually to get CO2 out of our body. And the reason why CO2 is important is because, one, we can't cope with ever increasing amounts of CO2, but also CO2 is going to be one of the primary things that changes our blood chemistry. So what they're specifically talking about when they say people have too low CO2, and that's going to make it that they don't have bioavailable oxygen, that is true, but it's actually not true typically in the high level CrossFit athletes in those populations. So that would be called what's creating a left shift in the oxygen dissociation curve. So imagine like hemoglobin and mitochondria, they play tug of war over this oxygen molecule. And at normal physiologic conditions, mitochondria is a little bit stronger, so it kind of always wins that game of tug of war, and it pulls the oxygen off the hemoglobin and it wins. If we breathe off too much CO2, and it creates what's called a left shift in the oxygen dissociation curve. In that instance, it's like that hemoglobin molecule gets like really yoked and really strong, and it just wins that game of tug of war, and it doesn't let mitochondria get that oxygen. And the reason for that is that hemoglobin increases its affinity for oxygen in that chemical environment. But the opposite could also happen. If you have too much CO2, hemoglobin decreases its affinity for oxygen too much, and it's almost like hemoglobin throws its arms up in the air in that game of tug of war and just gives up. So these protocols that are meant to improve athletes' CO2 tolerance are under the assumption that someone has too low CO2 already and that they actually have low CO2 tolerance. And that is typically true in like a general population setting. But when I've done physiological testing on athletes, I've actually seen that these protocols are very detrimental, because if you take a CO2 tolerant athlete and you chronically expose them to high levels of CO2 with these breathing protocols, you actually desensitize them to CO2 to the extent that they actually get peripheral and arterial oxygen desaturation. And you push that too far and you get CrossFit Games athletes starting to black out on the assault bike when we put them through physiological testing.
So you're noticing this specifically more with CrossFit athletes that are performing at maximal or just sub-maximal effort levels. Is that correct?
Yeah, and the reason for that is like we have 2 primary drives to breathe. We have what's called our carbonic drive and our hypoxic drive. Your carbonic drive should be your primary respiratory drive, and that gets tripped off when you have too high CO2. Your hypoxic drive should get tripped off when you have too low oxygen getting to your brain. And ideally, you should never really have to rely on your hypoxic drive. You shouldn't be starving your brain of oxygen. But with these CrossFit athletes, by virtue of the sport that they're doing, hitting high intensity work 5-6 days a week, they already have really good CO2 tolerance. So when you desensitize them to CO2 with things like Wim Hof breathing protocols and hypoxic breathing protocols, their carbonic drive becomes dysfunctional. So when they get very high CO2 levels, their brain doesn't signal them to hyperventilate and breathe off that extra CO2. And they don't get signaled to hyperventilate until they're getting too little oxygen to their brain. And by that point, they're already kind of at the door of failure. So when I've put these athletes through testing, I've actually got one CrossFit athlete to the point that he was getting down to about 88% arterial oxygen saturation. He's on the bike and he goes, is it normal that my arm's completely numb right now? I can't feel my left hand or my right hand. And I looked at his SpO2 on an oximeter and I was like, geez, this guy's probably going to black out in like 5 minutes if we don't stop him.
And for our listeners, what is a level that you don't want to drop below in terms of oxygen saturation?
I mean, ideally, this is talking about arterial oxygen saturation. I really don't want that to move at all during a workout. So I'd hope that you would start somewhere between 97 and 99%. And I'd hope that by the time you finish a workout, you probably didn't have any change, maybe 1 or 2% change. You really don't want athletes going south of 90%. And most people are going to black out between 85 to 90. So once you're getting that low, you're kind of at the point where you're getting restricted oxygen to your brain, your heart, your respiratory system, and that is dangerous. But if we're talking about venous blood oxygen saturation, which would be muscle oxygen saturation, you could take that to 0% and nothing's going to happen.
Okay. Super
interesting.
interesting.
Yeah, that really puts the 88% that you were talking about in perspective there. And so I'm glad that you went over that. But can you give us an example of one or two of the protocols that maybe some of our listeners could potentially be following right now that are also CrossFitters that maybe they don't need to be following in that regard?
Yeah, so and this comes down to what an athlete's limitation is. Like, I always hate to kind of like shit talk protocols, because when I hear these people talk about their breathing protocols, they're never saying these populations that shouldn't be doing them should do them. I think a lot of it is just athletes hearing them talk about it and misapplying these protocols. So for example, like some of the things in the Oxygen Advantage book, they're fantastic protocols, and everything that author says the protocol should do in the populations he tells to do them, 100% accurate. I think it's a great application. I think the issue is when people take those and they're not the intended demographic for those protocols, and they start layering them on top of their own training. So it's not an issue with the protocols, it's an issue with context specificity.
Sure. Yeah, absolutely. Absolutely makes sense. It's like the kind of the flavor of the month. I see people kind of doing external hip rotation stretches all the time, right? And most people have beyond sufficient hip external rotation. So it's kind of the same thing.
Yeah, and I think it's kind of like in the nutrition literature as well. Like, carbohydrates were demonized for a while, so people were restricting their carbohydrates and they were going on like high protein, high fat, and now protein is the thing that's being demonized in the nutrition literature. So it's like, okay, so you're just left with fat, no carbohydrates, no protein. Fat has been demonized in the past. So it's like if you're listening to every piece of research that's coming out and you're not contextualizing it for your own scenario, you kind of end up in a place where there's either nothing for you, like no foods are good for us because every macronutrient's terrible,
right?
Or you're trying to apply everything you learn to yourself without really thinking about what you need or what that low-hanging fruit is for yourself.
So one more quick question on this, just with your thoughts on it. One of the questions I asked to James Nestor with regards to breathing techniques when it comes to CrossFit type training was, is there any time when, because they're stressing the idea of nose breathing 100% of the time, and saying, even at, maximal levels of effort, CrossFit type workouts, do you recommend nose breathing? And they were saying, if you feel the need to start breathing out of the mouth, that your efforts are beyond what you're capable of sustaining. So you should drop it down a notch and only work out, only train at a level where you can nose breathe. What are your thoughts on that being possible?
I think that's a fantastic way to be very slow and not very good at CrossFit. I mean, if I've done gas analysis tests on people and you could actually measure the total oxygen flux and oxygen consumption when people are nose breathing, there's just a finite limit to how much tidal volume you could have with each breath and how much lung expansion you're getting. if we think about high level endurance athletes, some of them are getting upwards of 200 liters of gas exchange per minute. There's really no practical way to do that through nasal breathing alone. So I think if we're doing low intensity, it's great, but at higher intensities, it's not saying nasal breathing is bad. Perhaps we could breathe through our nose and our mouth simultaneously and get more total gas exchange. Because of course, if you could say if you can't nasal breathe, you're probably going too high of an effort and it's unsustainable. But by virtue of competing in a sport for time, whatever you're doing is going to be unsustainable. The name of the game is how long could you sustain this unsustainable pace?
Mm-hmm. And you apply that same technique to your middle distance running as well.
Exactly. Yeah.
Mm-hmm. Interesting.
Yeah. The big takeaway for me with James there was like, look, if you never train your limits with nasal breathing, then maybe that's something that you consider. Not to say that you shouldn't go beyond that a lot of the time to push yourself to a much higher level that you could. But I think his point too was that if you can improve your ability to work harder and do more work with nasal breathing by practicing that some of the time, then you'll increase your overall ability. What would your take be there?
Yeah, and I agree with that. And in that context, we're treating nasal breathing like a tool. It's a tool that has very specific applications, but just because that tool has specific applications, it doesn't mean I would use it in the middle of a race or when I'm competing in an all-out competition. I have to rely on some other tools for those scenarios.
Yeah. Yeah. For me right now, I mean, you probably know that I'm a lazy weightlifter. I do a lot of CrossFit and I have for the last 10 years, but I'm still not good at it at all. I mean, come on, Dave Durante beats me all the time in CrossFit
that gives you some
workouts,
perspective on how terrible he is.
Yeah. But for me, like, you know, what James was saying really made sense because it doesn't take me probably 30 seconds, if not less, into a CrossFit workout, and immediately I switch to my mouth. And there's no way that I could get a good CrossFit workout in with just nasal breathing. And so it really made sense to me because if I push my limits and my ability just with my nose, it makes sense that that's going to improve my abilities overall. Maybe if I do that, I can beat Dave someday.
Just throw a 105-pound with barbell in there, and you've already beat me.
105 pounds.
Yeah.
Well,
anything over 95 pounds, I lost.
Well, and speaking of weight, speaking of 95 pounds or weighted CrossFit workouts in general, one of the other things that I noticed on your Instagram page, this was maybe your last post or one that was very recent, you asked the question, why does my lower back always blow up during Metcons? And so this was just a curiosity that you have probably from complaints that you got as a coach. So as you dug into that, what did you find?
Yeah, so this was kind of like a tongue-in-cheek, like, why does my lower back always blow up when I do Metcons? Because I get this question all the time. People DM me, why does my lower back always blow up? I've had so many athletes. So this was a case where I spent a lot of time going through the research that is available, and I was looking for some potential solutions for this because most athletes, they've tried the most straightforward things. Oh, you improve your 1 rep max deadlift, and you improve your bending endurance. You do a bunch of high volume deadlifts, a bunch of high volume back extensions. And in most cases, those things don't actually work for improving your hinging endurance in Metcons, and athletes' lower backs still blow up. So it raises the question of like, well, if those aren't fixing the issue, what is the problem? So when we look at the literature, what it actually looks like is happening is that the athletes who do experience this, their spinal erectors are contracting enough that it's compressing the blood vessels in their spinal erectors, which means blood's not getting into those muscles, and then those muscles are desaturating of oxygen. And when you're sustaining a low oxygen environment in the muscle, that's going to cause local muscle fatigue. So it's all well and good. I read this in the literature, but my thought was, well, let's test this because I have the equipment that we could do this with. I have access to surface EMGs. I have access to muscle oxygenation monitors, and I have a lot of remote athletes that have these technologies as well. So I contacted a bunch of my athletes who have issues with their lower backs blowing up, and I gave them some workouts to do that I knew would blow their lower backs up. And I also gave athletes who don't suffer from that same issue the same workouts. The athletes whose lower backs blew up experienced exactly what they reported in the research papers. We saw a lot of mechanical compression, driving blood out of the spinal erectors, or they were getting venous occlusion in the spinal erectors, so blood pooling in those muscles. And because the Metcon's a very high density workout, there was never time for them to restore steady blood flow to those tissues. As a result, they experienced low back fatigue and low back pumping out. The athletes who didn't have issues with that have nice steady blood flow through those tissues the entire Metcon. So on the tail end of that, I spent a few months going through different ways of trying to figure out what are the interventions that actually fix this issue, because we know traditional local muscular endurance work doesn't solve the issue. Just getting stronger doesn't solve the issue. We have guys that have 600-pound deadlifts that their lower backs blow up on 135-pound deadlifts and Metcons. I don't think the solution is to get them to an 800-pound deadlift, particularly when we have guys that deadlift 300 that beat them in those Metcons.
Right.
So what we ended up coming out to is, like, in the post that you're talking about, there's a little article attached to it as well. We ended up coming up with like a little algorithm for how to solve this issue. So step one is, are you strong enough to do this weight? And that's a pretty easy thing to answer. If it's like a 225-pound deadlift in a Metcon, is 225 a relatively lightweight for you? You should know the answer, yes or no. If the answer is no, then you have to improve your absolute strength. That's going to be step one before we focus on any of these other fancy protocols. But if you are strong enough, and most of these athletes are, they're deadlifting at least 400 pounds, then we need to get more specific. So my second question for them is, are you able to do bending at this load for high reps in isolation, but you just can't do it in a Metcon? Yes or no? So if you could rep out deadlifts all day in isolation and you just can't do it in a Metcon, that's your specific issue. Then we go another branch down the decision tree, and I say, okay, you could do these deadlifts for high reps in isolation, but why can't you do it in Metcon? Are you an athlete who typically just experiences your muscles getting really pumped in Metcons, and you experience this blowing up phenomenon in a lot of muscles? Do you tend to put on muscle mass easily? Are you good at short, fast workouts, but not that great at the longer workouts? If the answer is yes, it's probably that you actually have a cardiac output issue. So the amount of tension that you're capable of creating in your working muscles is so great that your cardiac output can't push through that local muscle tension. And if that's the case, the way that you get better at hinging endurance is actually by doing cardiac output protocols. But let's take a step back. Let's say you're like, no, I don't blow up. That's not me, but I still can't do it in Metcons. Well, then maybe it's a diaphragm strength issue. Or maybe you're that athlete and you say, I'm very strong, but I could never do deadlifts for high reps, even in isolation and strength work. Well, then we go down a different branch of this decision-making tree. I'll say, is it a positional issue? Like, do you have full hip extension? Oh, no, I can't fully extend my hips. Well, that might be your solution there. If you can't fully extend your hips, you're keeping the spinal erectors under tension. If it's not a positional issue, is it a breathing issue? Could you breathe in all of these portions of the deadlift? If not, that might be the problem. Is it a muscle coordination issue? So you could contract well, but you can't relax your muscles fast enough. Then you're not getting blood flow in. So there's all these different possibilities, and it's actually pretty easy to figure out which of these is the problem for the individual. And if you could identify that, that's the low-hanging fruit. You address that and you take care of the issue, versus just like throwing a ton of shit at the board to see what sticks. So that tends to be how I approach a lot of these issues that CrossFit athletes run into.
For sure. Yeah. And, you know, for me, my go-to there would be to look at the position, look at the movement, and then also consider mobility, like you said, hip extension, hamstring, and then coordination. So is their low back overtaking everything, is so that their glutes aren't firing appropriately or in proper coordination with the rest of their body. So would you say that, you know, and you mentioned some steps there, would you stay with where my go-to is currently, that there's something that I should be looking for other than that first? What would you recommend for me?
I wouldn't even necessarily say so. Like, if you're dealing with people that are very weak, but I'm guessing just based on the kind of clientele I'm imagining you have, you're probably not dealing with athletes that are too weak to do high volume deadlifts. So in your case, it probably is athletes who are already quite strong. So a positional issue could definitely be one of those low-hanging pieces of fruit. But if it's an athlete, and this kind of gets back to, could they do high rep deadlifts in isolation but not in Metcons? If they could never do those for high reps, then I think your first intervention is probably the first thing I would go to as well. But if they're able to do them not in a Metcon, that's where I would start thinking about cardiac output and muscle contraction, relaxation speeds, and things of that nature.
Okay, perfect. Love it. Love it. Makes sense.
And can you give a protocol for the cardiac output, the person who is kind of limiting in that factor?
Yeah, so a really basic one, that 500 meter, that gradual ramping protocol that we talked about before, that would be a really good starting protocol for someone that we would consider delivery limited. Because for these delivery limited athletes, a lot of times their issue, and it almost sounds silly to say, but it's that they're too strong relative to their cardiac output. So
Sure.
for a CrossFitter, it kind of raises this question like, what is the point of being strong if it's at the expense of being able to get oxygenated blood into your working muscle? So for these individuals, we need to kind of shift that relationship. We need to improve their ability to get blood into the muscle versus their ability to utilize oxygen in the muscle. So it's almost like supply and demand economics. They're spending too much money relative to how much money they're getting.
Sounds like a problem for Chad for his.
I mean, I was hoping you wouldn't bring that up, Dave. That's
Well,
that's
I was giving you a
absolutely.
way out. This is something you got to do before our
It's
next
turning
workout
into
together.
a financial management
I'm
podcast.
not sure that the size of my quads will ever allow me to be very efficient with them, other than lifting heavy weights. So I'm not sure.
I want to talk about, this is just a slight branch off what we've been talking about, but specifically about muscle endurance. And it's another point that I've seen you discuss a little bit. Building muscle endurance and how just getting stronger does not kind of fix this problem. And it's something that myself, Chad, and Chris Hinshaw have been looking at and discussing quite a bit with our capacity WOD training. And kind of the protocols that we've been building off of with this, I'd love to get your thoughts on this idea of creating a system where we're looking first at, just like you do, this kind of assessment as to what the person's real issue is. Is it a strength issue, or is it more on the recovery side? Do they have issues kind of recovering from what's creating this lactate buildup? And so Chris has kind of taken a lot of what he's learned from his endurance training and allowed us to assist in applying it to skill-specific training on the gymnastics and weightlifting world. And the protocols that we've been putting together with a capacity WOD allow for this kind of fast twitch switching into slow twitch, creating lactate and flushing lactate through these capacity WOD workouts. What are your thoughts with regards to this idea of trying to create fatigue and then clear fatigue through a similar muscle pattern to allow for more muscle endurance to be built?
So this is where we get into like the top-down approach, like what we're actually doing from a training standpoint versus the bottoms-up or mechanistic standpoint. I think if we're going from a mechanistic standpoint, I might kind of tweak how we're looking at that problem, because this assumes that lactate is an issue. And this gets into a whole idea of bioenergetics, that lactate is actually it's not a fatigue byproduct. It's actually a fuel for resynthesizing glycogen in the muscle. So we actually want the lactate there, because that lactate is going to allow us to restore glycogen, which is going to allow us to restore phosphocreatine, which restores ATP. So this is moving away from those traditional like anaerobic and aerobic models into what we would call like a glycogen shunt model, where instead of classifying things as like alactic, anaerobic, aerobic, we could say like every type of training is aerobic and all training is lactic. So everything is lactic and aerobic, which is kind of contradictory through that traditional model. But in terms of the actual protocols that you guys are doing, what would that tend to look like?
So Chad, you want to give an example of one of your weightlifting workouts there?
Yeah, I mean, a couple of things that are very straightforward. So maybe we take 95 pounds on a thruster and we go as fast as you can for 12 seconds. And then we do a thruster with the PVC for 48 seconds, and we do that for 5 minutes. So 5 rounds, 12 seconds of sprint, and then 48 seconds of very slow, continuous movement.
Yeah, so to me, I'm like, that protocol makes sense. It would just be the underlying physiology of what it's doing. So I wouldn't necessarily be thinking about that as flushing lactate out. I would be thinking of that as you're probably restricting blood flow to some degree when you're doing those 95-pound thrusters. But then when you're moving to that lighter weight, you're shifting the type of hemodynamic reaction that you're getting in the muscle to allow for steadier blood flow. So you could continue that movement with steady oxygen supply for longer. So you're actually improving your ability to deliver oxygenated blood into that working muscle. And this gets into, Dave mentioned before, this idea of muscular endurance, and that getting stronger isn't necessarily the thing that we're going after for a lot of individuals. This comes down to this idea of what percentages of your 1 rep max you get the 3 different types of hemodynamic reactions. So the first reaction is called a compression reaction. So if you just kind of like put your arm out and you just like lightly flex your bicep a little bit and you're doing these little pulses, that's what's called a compression reaction. So when you're getting a compression, you're just lightly contracting a muscle and squeezing a little bit of blood out. But then when you relax the muscle, steady blood flow resumes. And for most people, this is going to happen between about 0 to 30% of a 1 rep max. So on a wall ball, warming up for back squats, you're probably getting compressions. Then the next reaction is called a venous occlusion. So arterial blood is still entering the muscle, but you're creating enough tension that venous blood can't escape. So when we're doing some bicep curls and we're feeling the pump, that's a venous occlusion. We could almost think of it like a hose. Your heart's like a spigot and your arm's the hose. So imagine we turn up that spigot and we clamp our wrist at the end of the hose and that water's still coming in and filling in the hose and pooling. That's that venous occlusion. The third reaction is what's called an arterial occlusion. So now we're clamping both ends of that hose and we're cutting off arterial blood from entering the muscle and venous blood from leaving the muscle. And that would happen greater than 70% of a 1 rep max for people on average. But what we get down to is that these population level averages, they could really misrepresent the individual. So if we were to test Chad, for example, with his massive quads that he mentioned earlier, I'd wager you probably get these reactions at a pretty low percentage of your 1 rep max. So me, I come from a middle distance running background as an 800-meter runner. So I get that first compression reaction from 0 to 45% of my 1 rep max. You might get that from 0 to 15 or 20% of your 1 rep max. I get venous occlusion from 45 to 90%. You might get venous occlusion from 20 to 60%. Mm-hmm. And are you guys familiar with that traditional like NME test concept where you take 85% of your 1 rep max back squat and you rep it out for max reps?
Yes, I believe I've heard of that. Yeah.
Right. So with this concept, people would traditionally say if you get 1 or 2 reps or 3 reps, which I'd imagine Chad would probably end up somewhere around there, you're very high neuromuscular efficiency. And if you get 15 reps at 85% of your 1 rep max like I would, they would say you're very low neuromuscular efficiency. Mm-hmm. But what we could see with a lot of the technologies that we have access to now that didn't exist when this training concept was invented is that the people like Chad who only get 1 or 2 or 3 reps, it's not actually because they have high neuromuscular efficiency, it's that they're getting arterial occlusion at that percentage of their 1 rep max. So if you're cutting off blood to the artery, you're not getting oxygenated blood into the muscle and you need oxygen to contract the muscle. So he fails after a few reps. If I'm getting 15 reps, I'm probably getting venous occlusion at 85% of my 1 rep max. So I'm still getting blood into my working muscles, even though the waste products aren't escaping. So in this way, we could kind of say, well, maybe resistance training and endurance training aren't actually all that different from each other. It all just comes down to the relationship between our cardiac output and our local muscle tension. So for individuals like Chad, well, what is your back squat as like a rough estimate?
I mean, currently probably around 400.
Okay, 400. And if you're a weightlifter and you are an occluder, you're someone who tends to put on muscle easily and you're explosive, there might be guys at 250-pound back squats who could beat you on a Metcon with 95-pound thrusters.
Absolutely.
So is the solution for you really to get stronger, to get better at thrusters? No, it's to just increase the percentage of your 1 rep max that you cut off blood flow to your muscle. And in the same way, those athletes who tend to be weaker, like myself when I used to do CrossFit, I occluded at an extremely high percentage of my 1 rep max. So if I wanted to get better at a 95-pound thruster, I'm not getting any steadier blood flow to my working muscle. I just need to get my 1 rep max up. So understanding these relationships for the individual tells us is the best way to get you better at muscular endurance tasks to get stronger, or is it to raise that threshold where you cut off blood flow? If that's something you even want to do, if your goal is to get yoked, you probably want to include at low percentages of your 1 rep max because it's going to make it really easy to hypertrophy because you're always going to be getting a pump.
Right. Well, I do want to beat Dave at a 95-pound workout one of these days. So that sounds like that's the only, either that or I just make sure that I only compete against him if there's at least 135 pounds on the bar.
Well, I've been working on trying to up my back squat to at least 150, and it's not quite there yet.
There you go.
Well, I think the trick is actually go around the gym and, when you buy like a 25-pound plate, most of them are usually between like 24 and 26 pounds. Sneak those 26-pound ones onto Dave's bar.
Yeah, and
now it's a 97-pound thruster and you're good to go.
It's all downhill from there.
Absolutely right. Anything over 95, he's done. He's done. Well, so I think we're coming pretty close to the end here, but I did have one other thing that I wanted to go over that I saw on your Instagram, and I loved it. It really made me, of course, it made me think about a snatch or a clean and jerk, but you talked about, different parts of the body being mobile and stable segments of the body,
Mhm.
mobile and stable segments. And you talked about looking at the body as a whole and how it works together, basically, and how it works together as opposed to those individual segments. And so, you put it as the mobile segments were ankle, hip, thoracic, shoulder, and wrist. And the stable segments were foot, knee, lumbar, elbow, and hand. When I first looked at it, I'm thinking, well, all of those need to be able to move. But then whenever I read a little bit more, I understood, and it made perfect sense with what I want in a snatch, for example. Absolutely, the ankle is moving many different times in many different ways. The hip as well. The thoracic, I need that to be able to, especially when you have a bar overhead, I need it to be able to arch. I need the shoulders to be moving, and I need the wrist to be in 3 or 4 different positions throughout an entire movement. But what I want to remain stable, even though they're moving, is the foot, the knee, the lumbar, the elbow, and the hands. Absolutely. So that little, I hope people will go take a look at that and read over that. But can you explain that a little bit more from your perspective?
Yeah, so this is a concept called regional interdependence. And like you said, the concept is that the body alternates mobile and stable joint segments. And you explained it really eloquently that those stable segments, they still have to move and be mobile to an extent, but their main job is stability. And what this model kind of points us to is it's a different way of assessing injuries. So if you have an athlete and you're like their lower back is always in pain, well, maybe what you do is you look at the upstream and the downstream joints. So if the lumbar spine is supposed to be a stable joint segment and the hips and the thoracic spine should be mobile, well, if they're suffering those lower back issues, look at their hips and thoracic spine, because if they don't have mobility in their hips and their thoracic spine, well, now the body still has to keep that alternating pattern. So because those joint segments are locked down, they're going to need to create mobility through their lumbar spine to create degrees of freedom for motion. And the lumbar spine should be a stable joint segment. So for them, they're creating that compensation pattern. So the way to address the lower back issues, actually addressing a thoracic spine or a hip issue. And then the same way, the knee should also be a stable segment. But if you don't have mobile hips and ankles, the knee is going to have to become a mobile joint segment, and that could also get you into issues. So this allows us to think of orthopedic issues from a full body standpoint, and we could even layer in something like fascial lines in here as well. One of the tests that a lot of people always get like their mind blown by, if you lay down on your back and you do like an adductor mobility test, do it, mark it on the ground, see how far you get. And then lay on your back and massage your neck and your jaw for 2 to 3 minutes, and then repeat that test again, and you'll get way more length in your adductor, because the superficial front fascial line inserts right here and it runs through the adductor. In the same way, if you have really tight hamstrings, roll out your feet on a lacrosse ball for a minute or two and you'll get more length in your hamstrings. It's this idea that everything in our body is connected to one another. So we can't really think of the body as these independent issues. Like your ankle issue might actually just be a hip issue. And oftentimes, obviously, if you fall off a sidewalk, it probably is an ankle issue if your ankle hurts. But if you're constantly suffering a knee or a hip issue and it's not getting any better with the treatments you're doing, it might be because you're treating a symptom and not the actual cause of your problem. And a lot of times when we work with CrossFitters, you think of the fact that a lot of them breathe with their traps, and going back to the nasal breathing, they don't know how to do that. So they're not breathing with their diaphragm. They get stuck in these thoracic extension patterns, and a lot of them end up with lower back issues as a result. And they're going to PTs and ATs to work on their lower back and nothing's happening, when in the end it was really just a breathing issue. So you teach them nasal breathing, their restore diaphragm function, their thoracic positions improve, and now their lower back's fixed. So I think the more we can take these big picture approaches, the more tools we have at our disposal, and we're actually running into these chronic issues with athletes.
I love that. I really love that. And I think, maybe the takeaway for the listeners out there is that, if you're doing a snatch, for example, and your foot is always moving around from side to side, maybe you're coming to the inside of your foot, the outside of your foot is coming off the ground, your knees are collapsing inside of your toes and shaking around like crazy, you're breaking in the lumbar, or any of those stable sections. Take these things that Evan is saying into consideration, and maybe that can help you out a little bit.
All right, Evan. So we are getting back to the last little bit of our podcast here, and we normally ask our guests a couple of quick questions before we get them off the air. You're cool asking a couple quick,
Yeah.
answering a couple quick questions?
Yeah, of course.
All right, first one's an easy one. I have no idea what we're going to get out of this one.
Yeah, I don't know.
Normally I kind of have an inkling of where the guest is going to go, but what sport or discipline do you prefer, weightlifting or gymnastics?
Oh God, I'd probably say gymnastics.
Yes.
Oh my.
I'm sorry.
Yeah, no, it's okay. You know, Dave's been on a little bit of a roll here. I had a good run there for 4 or 5 recordings, so I'm just gonna have to get back on track. But
I appreciate it. We don't have to know much more than that, but thank you very much, Evan, for another check on the box there. I'll take it. Next question: is there anyone that you think would be a good guest for us to have on our podcast? Anybody that you would recommend?
Do you guys primarily just focus on people in the strength and conditioning field, or you?
Nope.
No?
Nope.
Oh man, I think someone really cool, and this is partly selfishly because I want to hear this person talk about training with you guys. There's a guy named Andre Feldman who I think would be pretty cool to talk to. He's a physiologist and he dabbles in a lot of the same kind of technologies that I do as well, but he definitely has a really cool opinion. I think you guys could kind of cross-pollinate and have some cool discussions. So that would probably be a person I would recommend.
Sweet, thank you.
Nice.
Check him out.
yeah, very cool. Love these recommendations that we're getting, Dave. And man, Jordan's doing a good job of pulling you guys in, and I'm learning so much. I love this. But last couple questions here, Evan. What one book, movie, documentary, or TV series would you recommend?
One book.
And it doesn't have just one of those, and just, you know, whichever one that, if you're a book reader, you can recommend a book, or if you would rather, you know, if you're normally watching documentaries.
Yeah, I think I'm going to pick a book. And again, this isn't really going to be training related, but it might be interesting to some people, and it's just on my mind right now. There's a book called The Wild Life in Your Body. It's from a scientist that I really like. He's a big interdisciplinary thinker, so he kind of goes an inch wide and a mile deep and touches on all these different disciplines. And the book is essentially looking at the ecology of our body through like an environmental science lens. So I think it's just a cool book that people might enjoy.
What's the name of the author?
Rob Dunn.
All right, awesome. I'm gonna check that out.
Nice, very cool. Well, Evan, man, we really appreciate you coming on. It's been an awesome episode for me. I learned a lot for sure, and I'll definitely be keeping up with you. Now, is there anything you have coming up that you want our listeners to know about? Any parting words, or where can people keep up with you?
Yeah, I think the best place to keep up with me is on Instagram. That tends to be where I post most of my content. And for right now, I don't have anything going on that I need to tell the people about.
For sure. And how about Training Think Tank? Where can they check that out a little bit more?
Yeah, it's the same thing. Best place would probably be on Instagram at Training Think Tank, is where they tend to post most of their content, and also trainingthinktank.com.
Awesome. Well, to our listeners out there, as always, be sure to head over to powermonkeyfitness.com for services and upcoming events. Also, check us out on Instagram for regular teaching and technical content at Power Monkey Fitness, at Dave Durante, and at Ollie Chad. And on behalf of Power Monkey Fitness, we're your host. I'm Chad Vaughn with Dave Durante. And until next time, guys, thank you all for listening.